Okay, so we are on page 19 in the notes. And I guess the idea was last time we looked at problems that had one root in them or a fraction power in them. Now we're going to look at problems that have two roots in them. Some of these are very, very easy. Some of them are really not. That first example where I didn't give you any directions at all on like how to solve something like this, who wants to tell me what you think you're probably going to have to do? Jackson? Well, let's try it. If we do that, if we go and square both sides, I think we're going to get 4x plus 2 equals 3x plus 4. That looks pretty easy to solve. Go solve that thing. And when you're done, yeah, we still have to check for extraneous solutions, so when you're done, do your check. Bless you. Maybe 2 for the possibility? Well, it's not super pretty, but it works. Root 10 equals root 10. Yeah, we've got our solution. X equals 2. Does work here. I don't think we need to do more than one of those. If we have just a square root on one side and a square root on the other side, we can just square both sides. If it was a cube root on one side, a cube root on the other side, cube both sides, all of that. Where this gets harder is the next type of problem, where we have two roots, but you can't get a root on the left and a root on the right without dealing with other stuff in the problem. And there's a reason we have a half page of space to do work here. First thing we need to do, get one of the roots by itself and square both sides. We're going to get one of the roots by itself, and we'll square both sides. And I feel like the easiest way to do this would be to add the square root of x to both sides, because then I'll have this root by itself. The direction was then square both sides. Now, does anyone see something a little unpleasant that's going to happen? Jordan? Both sides? Yeah, and foiling with a root and all that kind of stuff there. I want to just add to my directions for number 1. Get one of the roots by itself and square both sides. I'm going to say in parentheses, foiling when necessary. The left should be really easy, though. Square that square root, you're going to get 2x plus 1. However, on the right, we're going to get something like this. I think I want to do the foiling together over here. Two x plus 1 is going to equal, well, 1 times 1 is 1. 1 times the square root of x is the square root of x. Square root of x times 1 is another square root of x. Square root of x times square root of x is like saying square root of x squared. What was that? X. Take 2 seconds and just combine like terms on that side. Root x, you can do something there. So 2x plus 1 equals 1 plus 2 root x plus x. Next thing I need to do, get the remaining root by itself and square both sides. Get the remaining root by itself and square both sides. I'm going to subtract 1 and subtract x. And I think that gives me x equals 2 root x. And I'm actually not going to divide. If I divide, I'm going to get fractions, and it may be easier if I leave it where it is and just kind of incorporate that into my squaring. I won't have the fractions to deal with. It'll make some things a little bit nicer. So we should be able to get x equals 2 root x. And then the direction was square both sides. So x squared equals 2 root x in parentheses squared. Square the left, x squared. Square the right, we get that thing in parentheses squared. On the left, well, that's just x squared like I had it. On the right, let's see. I need to square the 2, and I need to square my square root. I don't have to do any foiling here because it's not a sum. It's a product, which means I can distribute the square to both pieces. 2 squared gives me 4. Root x squared gives me x. And I had 2 times root x, so my answer is still a product. 4 times x. Well, the good news is the roots are gone. To finish this off, I'm going to solve and check for extraneous solutions. And because it's a quadratic equation, I think that means make it equal 0. Do some factoring, like GCF factoring, and get your answers out of that. Should become the equation x squared minus 4x equals 0. Take out your GCF, because then you'll get your 2 solutions. And to check, you're going to go back to the original problem that has 2 square roots in it. See if you can finish this thing off. Please make sure masks are over noses. Thank you. Maybe 0 and 4 is the 2 possibilities. And again, when you're done, do your plugging and check. Which one's good? What was that? Both? I don't think we've seen one of those yet. Oh, no, there was one in the homework that worked that way. But yeah, 1 minus 0 equals 1. That one's good. Square root of 9 minus square root of 4 maybe equals 1. So 3 minus 2 equals 1. Yeah, that's good. They are both valid. Like usual, as I've been saying, although you usually end up with one that's good, one that's bad, there could be two good ones, there could be two bad ones, there could be one of each. You really just have to go and test things. There's a lot here. The good news with these two root problems that have something else in them is they're always going to kind of work out the same way. The bad news is the work gets messy and stuff. We're going to do one more of these together. Then we'll do a little bit of practice with this stuff. I'm pretty sure there are 2 of them that will show up in the homework. And when we get to our test on Thursday, you will have one problem that has 2 roots and ugly things happening in the middle on there, because there's a lot here. Anything on this before we look at the next page? Okay, page 20. Fraction powers, but they're just 1/2. So how about you rewrite the problem with square roots instead? And I kind of think I still want to do a lot of this work together to make sure you have like a good, all the work is correct example in your notes. So our next step is to get one of the roots by itself. What do you want to do, Jackson? I think that would be the best one to move because it's already negative, and then if I add it, it'll become positive. So square root of x plus 3 equals -1 plus the square root of 3x minus 2. We're going to square both sides now. The left is easy. Priyanka, what's the left going to be? Absolutely, x plus 3. Why, Priyanka, am I not saying that the right is easy? What do I have to do? We've got to FOIL. I want to do the foiling together. So I'm writing that thing out twice. So I can FOIL -1 plus square root of 3x minus 2 times -1 plus square root of 3x minus 2. -1 times -1 should give you +1. -1 times your square root should give you -1, or just negative, square root 3x minus 2. Square root 3x minus 2 times this -1 will give you negative square root 3x minus 2. Oliver, could you tell me what's going to happen when I multiply those roots together? Well, hold on. So if you do actually multiply the stuff together, because these are differences inside the root, you'd have to FOIL and stuff like there. But there's an easier way. I'm multiplying a square root by itself. It's like I'm squaring a square root. So what are we going to get? That's what we're going to get over there. 3x minus 2. Please take like 10 seconds and just combine like terms on that side. I see a little bit of work you can do. Maybe -1 plus 3x minus 2 root 3x minus 2, I believe. Jordan, what did I do wrong? From doing 1 minus 2. Do you see where I got that from? Anyone? Anything yet? Leave the minus 2 root 3x minus 2 and move the negative 1 and the 3x to the other side. So add 1 to both sides, subtract 3x from both sides. PJ. So do you see where I got the 3x minus 2 from, first of all? So I'm just combining like terms now. I'm just doing 1 minus 2 over there to get the negative 1. Anything else? Okay, well then I'm going to add 1, and I'm going to subtract 3x from both sides. Negative 2x plus 4 equals negative 2 root 3x minus 2. Any questions on getting down to there? Could I divide both sides by negative 2? It would work. I won't have fractions. I think I am not going to do that only because you won't always be able to do so like in the homework. And I kind of want to show you what happens when I have that number out front, the square root and all that kind of. So I think I'm going to leave it, but you absolutely could moving forward with some other problems because you won't have any fractions with these. I'm going to go and I'm going to square both sides. I'm going to get negative 2x plus 4 in parentheses squared, and I'm going to get negative 2 root 3x minus 2, that thing in parentheses squared. What's happening on the left? Do that. Hold off on the right. (4x squared minus 8x plus 16, which we'll simplify in a moment. As for the right, I do not have to FOIL because it's not really a sum that you're squaring, it's a product. And that means we can square the first part, square the second part, multiply those together. Negative 2 squared gives me 4. What happens when you square that square root? What do you get? Hunter, what do you get when you square that square root? Yeah, square the square root cancels, and we get 3x minus 2. And again, I like that Hunter said times, because it was a product before, it's still going to be a product over there. What I need you to do right now is combine like terms on the left, distribute on the right, then move things to make it equal 0, but don't solve yet, because I'm going to show you how we can make this not quite as ugly as it's going to look. At least the good news is we're done with our roots in this problem. Now it's just a quadratic equation. and I was able to turn this into 4x squared minus 28x plus 24 equals 0. Can you raise your hand if you need like a moment to get caught up? Okay. I'm going to stop, and we'll go in a moment. Okay, now, we've got to solve this thing. Before you go and you make an x, I'm not going to give you hints like this on the midterm, but what should you do first? PJ? Always, always, always. I feel like I've been throwing those on cumulative reviews for many, many weeks in a row, and some people are still not thinking that. Think GCF first. There is one here. To be considered fully factored, you need to take out that GCF. We're going to take out a 4. X squared, PJ, what are you left with after you take out the 4? Good. Keep factoring. Multiply to 6, add to negative 7. That's not too bad. I think x minus 6, x minus 1 equals 0. Ava, what are your possible answers going to be? 0, 6, and 1. Well, actually, if there was an x out front, then I'd get a 0. But just a 4 out front isn't going to give me anything. I'm getting 6 by setting x minus 6 equal to 0 and all that. But if you set 4 equal to 0, you don't get anything out of that one. So only the 6 and the 1 are going to be your answers. Well, your possible answers here. So close. Yeah, what was that look for? What do you have to do now? Yeah, it's got to be back in the original. However, I think it's perfectly fine if you use the original with the roots rather than the 1/2 power. It's all the same thing. Definitely, though, has to go into something before you start squaring things. Check them both. Plug them in. See if they work. And that'll do it for notes, and then we're just going to practice one more, I think. Both good, both bad, one good, one bad. What's happening? What's the deal with 6? Good? Bad? Thumbs up if it's good, thumbs down if it's bad. Okay, I'm seeing thumbs ups there. So square root of 9 minus 18 minus 2 squared is 16, maybe equals negative 1. Yeah, 3 minus 4 is negative 1. That's good. Thumbs up for 1, thumbs down if it's bad. I'm agreeing with the thumbs down there. Square root of 4. minus square root of 1 maybe equals negative 1. 2 minus 1 equals negative 1. It does not. So 6 is good. Negative 1 is extraneous. There is a whole... Yes? That's what I've got. Positive 1. Thank you. This is the equal sign that did me in over there and looked like a negative. There's a lot that goes into these. In the homework, you have an entire page for work for each of those problems. If you do this in 2 lines by just like squaring everything to get rid of the square roots and then have no roots, that means you weren't listening to anything we just did, and I won't be able to give you full credit for things. It should look like this, and use these as models. Again, I'm not going to put one of these on your... Hold on, let me stop this.